On August 19, 2025, Ukraine executed a precise and devastating strike on a Russian fuel train bound for Crimea. Using just 7 Maluk V-2 kamikaze drones, operators ignited 150 tons of fuel carried in 30 wagons, turning the convoy into a rolling inferno. Within minutes, the explosion split the train, destroyed over 300 meters of track, and triggered a complete supply blackout. This single operation halted the daily flow of 3,600 tons of critical supplies, fuel, ammunition, and equipment to Russian forces in Crimea. The result was not only physical destruction but also a major disruption of logistics and morale. Could such low-cost, high-precision attacks redefine the balance of conventional warfare in the region? Before we begin, don't forget to subscribe to the channel and hit the notification bell so you don't miss any other videos. August 19, 2025 at precisely 8:01 a.m., a Russian fuel train of 30 wagons began its journey toward Crimea. Road convoys were being hunted, sea routes were unsafe, and so the railway remained Russia's only dependable supply artery. It was both mandatory and vulnerable. The track offered no alternate lane, no escape corridor, and the crew driving the diesel locomotive had no awareness that they were already under continuous observation. Within minutes, dozens of bomb-laden drones would descend on this column of fuel, turning a logistics line into a battlefield. The Ukrainian intelligence effort supporting this strike had been constructed in overlapping layers. The region offered poor visibility for unmanned systems, but this limitation was turned into an advantage by concentrating signal strength. Analysts built a hybrid situational map, optical and thermal satellite imagery cross-matched with commercial synthetic aperture radar packages, electromagnetic reflections, listening devices, and monitored GSM traffic near local stations. Locomotive telemetry was captured, and gaps in camouflage and jamming were penetrated. Signal intelligence confirmed both the day and the hour of transit, while secondary supply planning documents provided corroboration. Even the projected speed of the convoy was calculated, allowing planners to identify the exact intersection point for the strike. The drones assigned to the operation flew in a 3-segment formation. The first element designated targets, the second conducted dive strikes, and the third provided signal backup and return sabotage. The system of choice was the Maluk V-2, a modified kamikaze drone resistant to high temperatures. With an operational range of 210 kilometers, dual GLONASS and GPS guidance, and AES-128 encrypted data links reinforced by satellite recall algorithms, the Maluk V-2 was purpose-built for precision sabotage. Each airframe weighed 5 kilograms, polymer skin for reduced radar reflection, and carried a low-density explosive engineered to produce a shockwave at 9,000 meters per second. These drones were not intended to obliterate wagons by brute force. Their role was to trigger ignition. Ukraine categorized such missions as self-igniting targets, operations where the drone acted only as the spark, while the destructive energy came from the cargo itself. In this case, 150 tons of fuel would become the true weapon. The timing was calculated against the day's train schedule. At dawn, a civilian cargo convoy had cleared the line, leaving only the targeted fuel train on the rails. The composition of the train was carefully noted. 6 wagons of aviation fuel in the lead, 12 wagons of diesel in the middle, and 12 more with blended industrial fuel at the rear. The locomotive was a TE-33A diesel model, a 3,300 horsepower machine with 12 cylinders, capable of hauling heavy loads at 100 kilometers per hour. This meant the convoy carried not only flammable cargo, but also the kinetic energy of a fast-moving steel mass. The Ukrainian operators waited until the train entered the most confined, least accessible section of track. At that point, the first Maluk V-2 descended, slamming into the 14th car loaded with diesel. The explosive charge pierced the lower section of the tank. Diesel vapors ignited, pressure built, and within 7 seconds the adjacent 13th car filled with aviation fuel detonated in sympathy. The chain reaction had begun. Seconds later, the second wave struck the 16th and 17th cars, deepening the inferno in the rear half. The force of this dual impact fractured the formation, splitting the train in two. The front 13 wagons, momentum broken, derailed off the track. The rear 17 remained on the rails but were engulfed in spreading fire. Temperatures climbed above 620 degrees Celsius, cracking the concrete sleepers. The rails softened and bent. Structural integrity collapsed. The third wave then dove into the fourth car near the locomotive. Aviation fuel detonated, heaving the TE-33A off its line. The front wheel assembly dislodged, the engine compartment swelled under pressure, and the locomotive lurched sideways, crippled. The attack lasted precisely 6 minutes and 48 seconds. In that time, 7 drones had flown, struck and destroyed themselves. Each hit achieved its effect. By the end, 312 meters of track were ruined beyond immediate repair. Confirmation from the Ukrainian armed forces followed swiftly, accompanied by video proof. Media across the globe carried footage showing the fireball, the curling steel, and the crippled train. For 90 seconds after the last strike, cameras recorded only flame columns and black smoke. One thermal plume rose 27 meters into the air. Within 3 minutes, 200 meters of line were alight. Roughly 40% of rails were bent out of usable shape. Dry vegetation ignited instantly under thermal radiation, producing drooping flames that redirected the pressure wave downward, localizing destruction onto the track while sparing surrounding structures. The drones themselves had continued transmitting, each equipped with a low-resolution thermal camera in its nose to relay post-impact maps. Operators reviewed which wagons still burned and which remained intact. No second strike was ordered. Instead, the drones self-destructed after their reconnaissance roll. The attack had an additional dimension: electronic paralysis. During the first 10 minutes of the incident, Russian communications collapsed. The electromagnetic disruption generated by the drones severed links between protection units and central command. Only after 12 minutes did the first message reach logistics headquarters in Tokmak. For nearly a quarter of an hour, the battlefield was blind and silent on the Russian side. By the time the first fire brigades approached from the regional center, the blaze was impassable. 2 trucks halted a kilometer from the heat zone. Only specialized military fire control vehicles could enter, and they arrived an hour later. By then, wagons of diesel and jet fuel had been consumed. The fire raged for 2 hours and 46 minutes before diminishing. 6 secondary fires erupted across the landscape, started by flaming debris. On-site analysis showed rails bent into U-shapes, tensile strength reduced by 40% under extreme heat. At least 400 meters of track would require replacement, not only rails and sleepers, but also foundations, as the ground had settled by 12% under thermal shock. Signal cables had melted. Engineers estimated no fewer than 4 days for communication restoration, and much longer for track reconstruction. The railway artery to Crimea had been cut. Average flow through this line was 4 logistics trains daily, each carrying 900 tons. With one stroke, 3,600 tons of supplies per day were halted. 7 logistics centers in Crimea and along the southern axis were starved of fuel, ammunition, and water. Road transport could cover only 17% of demand. Sea transport was already shut down by naval drone attacks. The Russian rear entered crisis. 12 hours after the strike, the Russian command convened an emergency session. Initial reports framed the incident as a localized act of sabotage, a theory that collapsed once satellite imagery and circulating social media videos revealed unmistakable drone dive patterns and precise detonation points. These signatures left no doubt this was a deliberate remote-guided operation. By nightfall, the Tokmach-Orozhene railway line had been officially shut down. It was the only direct rail artery linking Crimea with the mainland. Ordinarily, 4 heavily loaded trains passed daily along this route, each hauling about 900 tons. That flow, approximately 3,600 tons every 24 hours, was abruptly reduced to zero. Ammunition dumps, forward refueling points, and water distribution depots across 7 logistic hubs in Crimea were immediately starved of supply. Alternative transport methods proved inadequate. Road convoys, already vulnerable to ambush and drone attacks, could replace less than 1/5 of the daily tonnage. Armored vehicle movements by road were impossible. Sea routes were closed after Ukraine's surface drone raids. The result was a bottleneck. Artillery batteries rationed shells, fuel shortages delayed tank deployments, and at least 2 battalions canceled movement orders on August 20 due to lack of fuel. The destroyed train alone had carried 150 tons of liquid fuels, including JP-8 aviation stock for forward airfields. In purely logistical terms, this was the equivalent of a mechanized division's fuel consumption for 3 to 5 days. In operational terms, the loss of 6 aviation fuel wagons denied more than 100 helicopter sorties. Each sortie unflown meant lost reconnaissance, lost close air support, and weakened ground defense. Financial calculations emphasize the asymmetry of the strike. The 7 Maluk V-2 drones cost Ukraine approximately $266,000 in total. The destroyed cargo's market value alone exceeded $2.5 million, not including the operational impact. Each drone had cost Russia many times its weight in disrupted missions, derailed schedules, and burned fuel. Strategic delay was another layer of damage. Rail engineers reported that 6 full days were required to rebuild the track bed, replace rails and sleepers, and restore melted signaling networks. For nearly a week, not a single freight train would traverse the line. This gap was swiftly exploited. Ukrainian UAVs targeted road convoys that had clustered near the northern exit of Crimea while waiting for the rail line to reopen. The first operation thus cascaded into a second, turning one strike into a rolling disruption. Russian air defense responded by widening its protective perimeter. 17 new radar stations were announced along the route. Yet the Maluk V-2's design minimized interception probability. Its low-altitude profile, often below 40 meters, reduced radar visibility. 4 adaptive algorithms allowed final flight paths to be altered until the last second, defeating predictive tracking. The drone's radar cross-section was too narrow for legacy systems to detect with confidence. As a result, the interception rate was effectively zero. The Kremlin introduced camouflage tanker convoys to mask real shipments, but the tactic was slower and less efficient. The main burden still awaited the repaired line, leaving Russia in a race against time. Beyond the material destruction, the attack delivered a psychological shock. Crimea's supply chain had been regarded as secure, buried under layers of military planning. Now it was demonstrated that 30 wagons of fuel could be transformed into an inferno by 7 small drones. Russian commanders recognized that every future crossing would be under threat. Each train would now require escorts, diversions, and heavier electronic protection. Every such measure translated into wasted personnel hours, drained resources, and operational fatigue. Ukrainian planners, conversely, showed that with inexpensive unmanned systems, they could paralyze a critical theater and force the enemy to expend far greater resources in defense than they themselves had invested in attack. From a military science perspective, the raid embodied the logic of asymmetric warfare. The drones did not merely destroy a train. They dismantled a logistical sequence, producing a backlog, forcing redeployment, and igniting fires that spread through both infrastructure and morale. The battlefield was no longer confined to trenches or artillery duels. It extended into railway junctions, depots, and command timetables. Fuel was turned against its owner. Communications were blacked out, and the timing of entire battalions was reset. The attack proved that Ukraine could shape the tempo of the war far behind the front line, turning supply corridors themselves into contested zones. In the aftermath, Russian engineers accelerated repair work. By the sixth day, track sections were reportedly restored, but vulnerabilities remained. Signal cables had been replaced hastily. Ground subsets from thermal shock lingered, imposing permanent speed restrictions on freight traffic. Even as rail traffic resumed, every train was a potential ignition point. Ukrainian silence on drone telemetry and signal logs suggested deliberate withholding, preserving operational secrets for reuse. The implication was clear. The same route might be struck again, at any moment, with equal precision. The August 19 operation entered analysis circles as a textbook example of how modern unmanned warfare reshapes conventional conflict. A strike costing hundreds of thousands inflicted millions in material loss and days of paralysis in supply chains. For Russia, it meant another layer of pressure on Crimea, already constrained by road and sea interdictions. For Ukraine, it reinforced credibility, the capacity to reach deep, to deny resources, and to rewrite the logistics of war. The rails themselves became symbols. Bent into U-shapes, blackened and twisted, they testified that traditional lines of supply were no longer safe. Every ton of fuel was not just a resource but also a risk. With each drone launched, Ukraine forced Russia to defend its rear with the same intensity as its front. This was not merely the destruction of a train. It was the demonstration that logistics, the unseen bloodstream of war, can be severed, ignited, and weaponized. A segment of steel track in Tokmak became a battlefield, and a convoy of fuel wagons became an arsenal against its own army. The strike illustrated how modern warfare has evolved. Inexpensive drones, layered intelligence, and timing can outweigh armored trains and regional command centers. The August 19 operation did more than wreck rails and burn fuel. It exposed a calculus now central to modern campaigns. Where logistics flows, so too flows vulnerability. The precision of the strikes, the layering of SIGINT and imagery, and the small cost of expendable airframes combined to produce outsized operational effects. In under 7 minutes, a handful of guided drones turned a single train into a sequence of cascading failures, derailment, thermal collapse of the superstructure, communications blackout, and a multi-hour denial of a crucial supply artery. The material loss, roughly 150 tons of fuel and hundreds of meters of unusable track, was measurable. The strategic loss, the interruption of daily deliveries totaling some 3,600 tons, and the subsequent rationing of fuel and ammunition across 7 logistics centers, was systemic. Tactically, the raid was textbook. Attack the node that shapes movement. By selecting the most congested, least accessible segment of track, planners maximized the chance that fires would become self-sustaining, that thermal energy would damage both rails and foundation, and that repair timelines would lengthen beyond simple rail replacement. The use of Maluk V2 drones as initiators rather than primary blast weapons was a decisive concept choice. These platforms acted as precise igniters aimed at fuel loads whose stored energy dwarfed the drone warheads. The result was a multiplier effect, small, low-cost munitions provoking large-scale destruction through the target's own materials. From an electronic warfare and command and control standpoint, the operation also targeted information flow. RF interference and deliberate electromagnetic disruption produced a communications blackout lasting approximately 10 minutes, delaying the first contact between field protectors and central command by 12 minutes. That window was tactically significant. It prevented coordinated countermeasures and prolonged the period during which response units could not accurately assess the unfolding damage. The post-strike thermal mapping performed by the drones allowed Ukrainian operators to validate effects in real time, judge which wagons remained viable targets, and then end the operation without expending additional assets once the campaign objectives were met. The immediate operational consequences cascaded quickly. Fire suppression could only begin after military fire control vehicles forced access an hour after impact. Standard regional fire trucks could not penetrate the heat zone. The fire burned for 2 hours and 46 minutes and spawned 6 secondary blazes from airborne incendiary debris. Track metallurgy failed as rails softened and bent at temperatures that reduced tensile strength by up to 40%. Ground settlement and damage to concrete sleepers and signaling cables extended repair timelines and imposed long-term speed and weight restrictions on the restored section. Those engineering realities translated into a logistical vacuum. Road alternatives could carry at most 17% of the line's daily throughput, and maritime options had been previously constrained by separate naval drone interdictions. The operational tempo of several frontline battalions slowed, planned movements were postponed, and air operations that relied on JP-8 deliveries were constrained by a shortfall equivalent to hundreds of helicopter sorties. Strategically, the strike rapidly became a case study in cost cost imposition. The economic tally, approximately $266,000 in expenditure on 7 Maluk V2 units against a cargo and operational loss measured in millions in days of paralysis, illustrates the asymmetric accounting now central to conflict economics. More important is the resource accounting beyond immediate cost. Personnel diverted to escort and repair, the tempo lost while awaiting reconstruction, and the persistent requirement to harden or reroute a key artery. Russia's announced response expanded radar coverage, masked convoys, and longer-term infrastructure investments, imposed both time and manpower costs that extended the penalty of that single morning's operation. Psychologically, the strike punctured assumptions. Crimea's supply chain, once considered durable because of its rail reliance, proved vulnerable to a relatively low-cost, remotely executed method. That shift forces operational planners to treat rear-area logistics with frontline caution. Every rail crossing now demands additional escorts, electronic protection, and redundant routing, each of which consumes assets and increases exposure elsewhere. For Ukraine, the operation reaffirmed the potency of layered intelligence, precision timing, and unmanned systems as instruments of strategic shaping rather than solely tactical attrition. The wider doctrinal implications are significant. This operation demonstrates how modern conventional warfare is increasingly hybridized. Kinetic effects are achieved not only through large-caliber artillery or airstrikes, but through the integration of commercial imagery, signals exploitation, and low-signature unmanned systems. It reframes logistical nodes as active battlefields. Supply trains, depots, and junctions become legitimate targets not merely for attrition, but for tempo control. The concept of self-igniting targets highlights the tactical efficiency of using an enemy's own material as a force multiplier, while the operation's success underscores the necessity of adaptive detection systems optimized for low-altitude, small RCS threats. There are limits to the lesson and risks for the attacker. Precision intelligence and permissive access were enabling conditions. Without those, the attack's probability of success would drop. The decision to withhold drone telemetry and thermal logs afterward indicates an operational discipline intended to preserve tradecraft and deny the adversary easy countermeasures. Conversely, the adversary's likely responses, distributed logistics, hardened tankers, electromagnetic shielding, and increased air defense assets will raise the cost of future strikes and shape a new logistics defense competition. In the aggregate, the August 19 strike stands as a concise demonstration that in contemporary conflict, disruption can be as decisive as destruction. A 6-minute action produced days of operational paralysis, required thousands of hours of engineering labor to repair infrastructure, and forced strategic reallocations that ripple through frontline planning. The rails at Tokmak became more than metal and concrete. They became an axis of strategic pressure, a place where asymmetric methods translated into conventional advantage. This account closes as a professional chronicle, precise on time and place, detailed in effect and aftermath, and lucid about both technique and consequence. It records a small strike with disproportionately large effects, an operation that leveraged layered intelligence, modest unmanned platforms, and the inherent volatility of fuel to impose systemic friction on an opponent. The tactical sophistication and logistical foresight behind the raid will be analyzed in military circles for lessons on both defense and offense. It is a reminder that in modern warfare the rear is rarely safe, and that supply lines, once taken for granted, can become decisive terrain. In your opinion, how do such precision strikes shape the future of conventional warfare between Russia and Ukraine? Please share your comments below the video. Don't forget to subscribe to our channel and like the video. Thank you for watching.